Okay, in this video we're going to introduce Laplace transforms or the Laplace transform. So if we have got a real valued function f of t defined in the interval between 0 and infinity, then the Laplace transform, which we're going to abbreviate LT, is defined by this integral here, where the parameter s is a real parameter that is greater than 0. So for this reason, the Laplace transform is belongs in the class of what we call integral transforms. There are a number of other transforms which are defined by an integral of some sort. So because its definition, it's defined in terms of an integral, it's called an integral transform. Now notice that when we integrate this and plug in the limits, the parameter s is going to be the only variable thing that is going to remain there. So in fact, what we usually do is we write this as a f big F, which is a function of s. So it is a customary thing to represent the transform of a function f by its uppercase. So the transform of small f is big F. Now, the other thing that you're going to notice is happening here is that so we start off in T F space. So let me just make a graphical. So we start off in a space where the independent variable is t and the dependent variable is f. So this is in T F space. Then we make the Laplace transform, and then this takes us to the space where the independent variable is now s and the dependable variable is big F. So that means we're going from TF space to SF space via the Laplace transform. This is what the Laplace transform does. So from here, you can see that we write Laplace transform of f of t is f of s. If we want to go in the reverse direction, then we take what is called the inverse Laplace transform. So as you can see, for the Laplace transform, we use the curly L symbol. So the reverse of that is the inverse Laplace transform. So if we take the inverse Laplace transform of f of s, then this is going to give us small f of t. So the Laplace transform is taking us this way. The inverse Laplace transform is taking us backwards. All right, now just one main application of the Laplace transform that we are going to look at in this series of videos is in solving ODEs. So we're going to look at how to use the Laplace transforms to solve ODEs. Just going to make a schematic of what is going to happen when we use Laplace transforms to solve ODEs. So what's going to happen is, if we start with an ODE, let's just do an example. Suppose we have got this ODE here, y dot plus 3y equals to 1. Suppose the initial condition is that when t is equals to 0, y is equal to 2. So we want to solve this. So if we start off with this, so what we can do is we can take the Laplace transform of the ODE. Now when we do that, the Laplace transform converts or transforms the ordinary differential equation into an algebraic equation. So that is the usefulness of the Laplace transform. So here we're just going to have an algebraic equation. An algebraic equation is typically easier to solve than an ODE. In this particular case, the algebraic equation is going to be s squared y plus 3s y is equal to 2s plus 1. Okay, so in this equation, the unknown is this big Y here. Remember, we said whenever you take the Laplace transform of y of t, then it's going to give you, the Laplace transform is denoted in terms of the uppercase. Then once we have got this situation, then we can solve this, and so this process is typically going to be much easier than if we had to solve this ODE here. So we solve this algebraic equation. In this case, if you just factor out capital Y this side, then you're going to notice that capital Y is going to be 2s plus 1 all divided by s squared plus 3s, and then the solution is done. Then what remains is for us to take this back to the t space. So what we do here is we take the inverse Laplace transform and then we express the solution in terms of the original variable. So this case is going to be yt equals to something something something. All right, so that is the schematic of what is going to happen now. So just to superimpose what's going on here, so on the left hand side of this dotted line, here we are in the t y of t space. On the right hand side of the dotted line, we're in the transformed space. So here this is t and that is y in terms of our coordinates. This is s and that is big Y. So that is what happens when we use Laplace transform. We start off with an ODE, we take the Laplace transform, we end up with an algebraic equation, we solve it, then we take the inverse Laplace transform. So the two steps that are going to be involving here, which we are going to have to train ourselves and prepare towards this first step here, so we need to develop skills of taking or finding Laplace transforms, and also we need to develop skills of taking the inverse or finding the inverse Laplace transforms. This step here is typically going to be straightforward. All right, so thank you for watching this video. In the next video, the next series of videos, actually, we're going to start developing skills of how to find Laplace transforms, and then afterwards we'll develop skills of how to find inverse Laplace transforms. Once those are sorted and developed, then we'll start looking at how we can use Laplace transform to solve ODEs. Right, so thank you for watching. Please do not forget to press the subscribe button to support the channel, and if you've got any questions, you can post them in the comments section. Okay, thank you.